Check, check. Yeah. Okay. Hello, Arish.
Sir, good afternoon.
Good afternoon. Good afternoon. So your friends are yet to join. I hope they are not planning to do some kind of bunking. So your classes have already started. Of course, I'm getting the notices through TCS. TCSM. Okay. Okay. So they have also started joining. Very nice. So let's wait for 2 minutes for others to join. If they are joining late, then we will start. Check. Yes. So welcome back after Diwali. So we will be continuing what we were discussing. I hope everybody's Diwali was very safe and relaxing. Yeah. Uh, so did you burst crackers or did you just yeah? I mean, there are various alternatives. One alternatives to crackers is making those paper crackers, which you can flick and they make a sound. Yeah, all those
There are
things.
many eco-friendly crackers available also in the market.
Yes, eco-friendly crackers are available with very less smoke and yeah, pollution. Yes, yes. Our diyas are best, I think. Yeah. Anyway, I mean, I don't think when uh, the Ayodhya people welcomed Ram, they burst crackers. They, of course, they might have lit diyas. Yeah. So diyas are the best. And of course, flowers, etc. Flowers also, I mean, for every ritual, I have begun to believe that if you exchange small flower pots, then breaking flowers, I mean, if you break the flowers, if you pull out the flowers from the plant, they essentially are dying. Yeah, so it's better to exchange small flower pots than flowers as such, because then nothing has to die, no living being has to die for that, for our celebration. Yes, so that is nice. Yes, so we were discussing, of course, we will do revision. So this is our fourth unit, our last unit. So we will be finishing the basic concepts. Then we will be doing revision when all of you come to the campus. Of course, I see a couple of you in the campus already since the last couple of weeks. So all of you come and we have physical classes in one of these classrooms, maybe in the new building which is being ready. So by the time you come, it should be ready. So we can we can have classes there. Yeah. So we will do a lot of revision. Revision in the sense, I won't simply be repeating. I will be asking some questions. Yeah, maybe a simple problem, and to essentially find out till what it is clear to everybody. Yeah. Then after that, we will extend it. We will make it more clear. We will do more practice. So we will do revision like that. It won't be uh, just repetition of what we have already discussed. Some part of it will be repetition, but majority will be finding out till what extent in each topic it is clear for everybody. Then we will extend it. Yeah, we will discuss further from that point. Yeah. So let us discuss three things today. We are discussing regression. So we have understood the basic concept of regression, what essentially we are trying to do. We are trying to fit a line given our data, given our data of at least two variables. We are trying to fit a line to that data. So I'll share the screen. So we saw this data points, this sample data, temperature and sale of pakoda. Yeah. So we saw that if we plot the points, if we plot those points, temperature versus sale of temperature on x-axis, if yeah, there is no issue in audio and video. Check.
No issue, sir.
Okay. No issue. Okay. Yeah. So we can plot the points, circles with the center darkened. These are all the points which we have in table. Yeah, so these are the same points, temperature and zero, corresponding zero. So that we can plot those points, those 4 points in this way. And then we realize that, of course, our target is to fit a line to this data, but there can be multiple lines which can appear to fit the data. So how to decide which line fits the data best? So we will discuss today what is meant by best fit. What is meant by best fit? How to find these coefficients? How to find these coefficients? We discussed that this is the equation of the line y equals mx plus c, where m is the slope that basically shows the inclination. Slope shows the inclination of the line. Line kitna tedha hai, kitna seedha hai, that is shown by the slope. That is measured by the slope. And c is basically the y-intercept. That is where the line cuts the y-axis. Where this line, the line of our best fit, where it will cut the y-axis. That is called y-intercept. Okay. So how to find m and how to find c? These are the coefficients. If we know these coefficients, we know the line. Yes. So that is the logic. And what is meant by how can we measure how to what extent our line is representing the data set? Of course, we found the line of best fit, but suppose, for example, what I mean by this is so suppose the data as such is distributed a lot. Yeah. If we try to find out, we might be able to find out some line say like this, which data based on the parameters, based on the criteria we are just going to discuss. Yeah, there is one situation like this, situation one, and there is the second situation where the data itself, no fault of the line here, no fault of the line, but the data itself in the second case is very distributed very nicely. Yeah. So we can very easily find out a line which fits our data in this case. In both the cases, we tried to find out a line which fits our data. But in the second case here, we know that this line fits better, just describes the data better. Yeah, because there is very less variation around the line. So we know that the data fits, the line fits the data points much better than in this case, than in this first case. Okay, so there is a measure to tell us that we will find the line of best fit, but how good the regression is. Although in all cases we will be finding out the line of best fit, which fits the data in the best possible way. But still, how good that regression line is, there is a measure for that. In the second case, as we just discussed, the line is a much better representation of the data points. So that measure is called R square. Yeah. Very popular, very widely used measure for this. You will see this in various different contexts. So that concept, that measure is called R square. How good is the regression line? Basically, in a little bit rough language, how good is the regression line? Okay. So in today's class, we will do these three things. First thing we will do is what is meant by best fit. Best fit means what? Then the second thing we will do is we will find out these coefficients M and C. And the third thing, I hope we will be able to discuss that also today. The third thing, we will try to find out how good is the regression line. The measure R square. These three things we will discuss today. So going one by one, what is meant by best fit? Yeah. Now y-axis and x-axis are there. And we have data points. So now we try to draw different lines. Initially, we do not know which line fits best. So we are trying to define the criteria. This can be best fit. Similarly, this can be best fit. Yeah, you can say this is this second line can also be considered as fitting better. Yeah. So how to what criteria do we use to decide which line fits better? So our criteria is the distance of these data points from the line. Yeah. So if we consider this first line, so distance, that is perpendicular distance from the line of this point. This is our original data point, right? These three are our original data point. So this distance, yeah, this distance from this line, yeah, and distance of this point from our first line, perpendicular distances, perpendicular to the line, not perpendicular to the x-axis or y-axis. That is a common confusion, which should be clarified in the beginning itself. Yeah. The distance what we are considering are perpendicular distance from the line of each of the data points. Okay, then the distance from the third point. So the criteria we decide, and mathematicians, statisticians have decided, is the line of best fit will be called the line of best fit when the sum of squares of these distances, yeah, say, let us give them names. Let us give them names. So this is D1, or going forward, we will use the term error for these things. So let us use E1, E2, E3. Yeah. So if this line 1 is the line of best fit, then E1 square plus E2 square plus E3 square will be less than the distances from any other line. Yeah. This distance will be minimum. Then only we will say that that is the line of best fit. And then only we will say it is the regression line. Again, I will repeat. So here in this case, we have discussed the line 1. I have given this name to the line 1. Okay. From line 1, we have calculated these distances from our actual data points, perpendicular distances from this particular line. Then we add square of those distances. Okay. Now taking the second line, let us give it another name. So let us call it line 2. This I am calling it as line 2. So the from the actual data points, we can calculate the distance from this line also. This second line also, from the second line also, we can calculate the distances of our actual data points. How will they look like? Okay, so this is the distance from the first point from line 2. Now again, this distance, is the distance of our actual data point from line to perpendicular distance. Here also perpendicular distance. In this case also perpendicular distance. Here again perpendicular distance from this line. So if we consider line 2, the distances we have to consider to see if line 2 is the best fit or not are these distances. Let us give the distances, these distances also name. Let us call them E4, E5 and E6. So if we calculate that, E4 square plus E5 square plus E6 square. So we can draw any number of lines which appear to fit the data points. These are only just 2 examples. We can draw almost infinite number of lines. We can actually draw infinite number of lines which may appear to fit the data points. But how do we select which line fits best? By this criteria. We calculate the distances from our actual data points from the line, and we sum the square of those distances. Our line of best fit will have that sum minimum. Yeah. So then only we will call it the line of best fit, and then only we will call it the regression line. So this is the criteria. Sum of square of distances from the line of actual data points should be minimum. Okay. Now, fortunately, mathematicians, yeah, I would call them mathematicians only. Yes. So mathematicians have found out how to calculate the coefficients so that this automatically happens. We can calculate the coefficients in the sense this M and C, this slope and y-intercept, we can calculate in such a way that we will automatically get the regression line. We will get a line which fits best. What is meant by it fits best? It means the square of distances of actual points, our actual data points from the line will be minimum. Suppose this line 1 turns out to be that best fit line, then this E1 plus E1 square plus E2 square plus E3 square, this thing written in green, this thing will be less than this one. E4 square plus E5 square plus E6 square. Yeah. Or any line 3, if we draw different lines. Yeah, from now I'll do something like this. So suppose we draw this line, this line, this line. From each of the lines, we can draw the distances of our actual data points. If line 1 is the line of best fit, then this sum will always be the minimum. This will be less than the distances from any other line. Yeah. So there is a way to calculate the coefficients, that is M and C. The general equation of a line is y equal to mx plus c. Here M and C are called the coefficients. Okay, so we can find out the coefficients in such a way that the line we get in that case is the line of best fit. Okay. Now how to do that? So to calculate M, we will be using correlation. To calculate M, we will be using correlation. That is why just before discussing regression, we discussed correlation. So Now we are going to the second part. We are going to discuss, that is finding the coefficients. Yeah. Now to calculate m, we use correlation or Pearson's correlation coefficient. That is the only correlation coefficient we discussed anyway. Yeah. So using Pearson's correlation coefficient. Okay. So we can do that. And once we get m, what we will do is we will put uh, the mean of phi in place of phi. We will put mean of phi in place of phi, and m we will have, say m is 4. Yeah, suppose just for example m is 4. Then in place of x we will put mean of x. Then the only unknown will be c. Okay, so from this equation we will be able to find out c. Why we can do that is, whatever the line of best fit will be, it will pass through the mean of x and y. Mean of x, that is what is there in x-axis, and mean of y, that is there in y-axis. Whatever our line of best fit is, it will pass through these two means. Yeah, that is also a property, or that is we can say mathematicians have already found out. So the lines may look very different. Yeah, but if it is a line of best fit, it will be passing through the mean of y, that is this variable on y-axis, and mean of x, that is this variable on x-axis. Yeah. So by substituting mean of y and mean of x in the equation, first we will find out m, and then the only thing remaining remains c. Yeah. So that way we can find out c. So how do we use correlation to find out this m? Now the question is that. So that is, so b1 is the coefficient. As I might have mentioned earlier also, sometimes it is represented as b1 and b0. Sometimes it is represented as m and c. Both way are same actually. M here in the first equation, m is represented as b1. C is represented as b0. You can use either of the notations, y equals mx plus c or y equals b1x plus b0. So this m, that is the slope, is given by correlation coefficient multiplied by standard deviation of y divided by standard deviation of x. So that you saw in printed way on a PPT. M we can find out by correlation coefficient multiplied by, that is actually standard deviation. They have represented by S. We have so far represented it by sigma. This notation is called sigma, right? So M is found out in this way. This R is the correlation coefficient, or say long with arrow. This R is this correlation coefficient. Okay. So correlation coefficient, we know how to find. Standard deviation, of course, we have seen multiple times. Yeah, standard deviation of y and standard deviation of x. These two we can find out, and correlation of here x and y, of course, correlation of x and y we can find. So do you recall how to find correlation of x and y? After that, to find out the regression line, it's not much of a challenge. Yeah. So after we find out m, we, of course, to calculate m also, to calculate this correlation coefficient also, we would be first finding out the mean of y, then mean of x. Yeah. So to do any calculation, almost any calculation in statistics, we will first find out the mean of the variables. So we will have those means already while calculating m. So we will just put those means in the equation together with the value of m, which we will calculate, and then we will calculate c. Yeah. So the challenge here, the next challenge comes to be find out m. And to find out m, we have to first find out the correlation coefficient. Do you remember how to find out correlation coefficient of two variables? Take a minute to recollect. You can refer your notes. Yeah, take a moment to recollect. I'll close my voice. Okay. Okay. So did you get to the formula? The method to find out correlation? Yeah. Ways. R is equal to covariance between the variables, say x and y, divided by standard deviation of x, standard deviation of y. Of course, you would realize that here also standard deviation divided by standard deviation is there. So if we put covariance instead of correlation, this standard deviation of y will cancel, but that is not usually focused on. You can do that little bit of transformation, a little bit of, I won't say simplification because it doesn't simplify things. We anyway have to find out covariance. Yeah. So covariance of x and y divided by standard deviation of x multiplied by standard deviation of y is the formula for correlation coefficients. This small r, correlation coefficient. Now, how to find out covariance of x and y? Do you remember? It's very simple. How to find out covariance of x and y? This thing here. How to calculate covariance? Do you remember? That is summation of x minus x bar multiplied by y minus y bar. Covariance is simple. So we will take one variable x and y. One step, we will calculate the x minus bar, y minus y bar. Yeah, we will keep then the second value of x, using the second value of x and second value of y. We will calculate x minus x bar, y minus y bar. We will add to the first product, then we will keep adding like this summation. So we will do that. I think rather than till our will find out actual iteration for the data, the temperature and Poda seal. We will find out the iteration line for that. So covariance is this. Standard deviation, do you remember? Yeah, you just appeared for the exam. So standard deviation, we definitely remember. So separately, you will find out the standard deviation of x and standard deviation of y. How do we calculate that? That is summation of x minus x bar whole square divided by n. And here you will have some square root of summation of y minus y bar whole square divided by n. Okay. Not why we do not use covariance. If you reflect on it, use taking a look at the formula and doing a couple of samples, you find out the covariance. If you find out the correlation, you will realize that by finding out the correlation coefficient, we neutralize the effect scales. See, x and y can be measured in various different scales. X may be in 10, 20, 30 like that. Y may be in 10,000, 20,000, 30,000 like that. So covariance will not be able to accommodate that. Covariance will just give a positive or negative value. Based on that, we can understand if the two variables are varying in the same direction or opposite direction. But to what extent they are varying together, and to compare coefficient between two sets of variables, covariance will not help us much. It will just give us the direction, whether two variables are varying together in the same direction or in the opposite direction. But to what extent, it is not telling us. It does not tell us. When we do a couple of examples, the effect of scale will be apparent. So by dividing the covariance with standard deviation of the variables, that is standard deviation of y, we neutralize the effect of scales, different scales, in which x and y may be measured. Yeah. Not only units, x and y can be measured in different units. Not only that, it can also be measured in different scales. So by dividing it with standard deviation of these variables, we neutralize that effect so that we can compare correlation between different data sets. And we will be easily able to tell whether the extent to which two variables, say variable temperature and sales, what is the strength of to what extent they are varying together compared to, say, uh, rainfall and sales. Rainfall and sales is one set of variables. Temperature and sales is another set of variables. We can have data in both the sets, and we can find out the correlation coefficient, and we can compare where the strength of relationship, that is to what extent they are varying, is higher, where the strength of the relationship is higher. So for that, correlation coefficient is a much better measure because it neutralizes the effect of scales on which the two or more variables are measured. Okay, that is why we use correlation coefficient. The reason statisticians came up with correlation coefficient in the first place. That was a little bit of repetition. We might have discussed that long back before Diwali. Yeah. So this is how correlation coefficient is calculated, and standard deviation. Anyway, to calculate the correlation coefficient only, you had to calculate the standard deviations of x and y. So you can just substitute standard deviation of y here, and standard deviation of x here in the denominator in the formula for m, that is the slope of the line of best fit. So when we calculate this slope, after we calculate this slope, we will put it in the equation of the line with y as y bar in place of y, and x bar in place of x. So the only unknown remains to be c. Yeah. Suppose, just for example, say m, suppose again we say m, suppose comes out to be 4. Yeah. And did we already calculate x bar and y bar here? Not yet. Okay. So you can calculate x bar and y bar. You can actually calculate. I think we calculated in Excel. So now, roughly, if I calculate, say, these, yeah. So let's say x bar is 22 and y bar is 1800 something. You can calculate and verify. Okay. So just for example of putting the actual values, I would see at end in that. So x bar is 22, y bar is after calculating m, yeah, suppose m equal to 4. After calculating actually m comes out to 4, the next step will be we will put y bar in place of y, that is 1800, and m, that is 4, multiplied by x bar, that is 22 in the above case, plus c. Yeah. So by simplifying this, we will be able to calculate c. Okay. So we will have c, m we already calculate. So we put say, suppose c, how much will be c? Can I calculate? This will be 88. So 1800 minus 88. So roughly it will be yeah, 1712. Just for example, 1712. C is 1712. So we put C and M back in the general equation. General equation is what? Y equal to mx plus c. Now, by all this process, we have calculated m and c. We can put this here. So y equal to 4x plus 1712. This will be our regression line, equation of the regression line. Yeah, that is the line which best fits our data. what is meant by best fit, that also we have discussed today extensively. Yeah, I have not actually calculated M and C because we will do that. All of us will do that as an exercise. So the data given is our previous data, temperature and sale of pakoda. Now, if you have understood all this, the task for us is calculate the regression line for this data. Calculate regression line, equation for regression line. For this data. Or rather than calculate in this situation, I would say derive word fits better. So derive the equation for regression line for this data. So what all you would do. This is the exercise. This is yeah. This is feasible also. We will discuss R square, that is the measure of how good the regression line is for next session, not today's session, but to calculate the regression line for a given data that we can do now. So this is the given data, temperature and sale of pakoda. You have to do all the processes, that is find out M and C, find out the slope and y-intercept, and then you can then you have the line of regression, the regression line, the equation for regression line. If that is over early, then you can say predict if the temperature rises to 29 degrees Celsius. Now the question you will be answering is, if temperature is 29 degrees Celsius on some day, then what will be the sale of pakoda? And what is likely to be the sale of pakoda? Of course, we cannot be definite. Pakoda on that day. Yeah, 26, of course, it's not given here. It's only 25, 28, 20, and 18. 26, 29, sorry, 29 degrees Celsius is not given here. So you have to put 29 in place of x in the equation you find out. 29 in place of x in the equation you find out to have the predicted value of sale of pakoda, that is y. So if you want, you can do this later, but at least do this today. Right now, again, I'll switch off. You can ask me to project some particular part of the discussion today. Yeah, so first you should be noting down this data. If your notes do not already have this, you can note down this 8 values, temperature 4 values, and sale of pakoda corresponding 4 values, so total 8 values. Please note this down, and if you want, I can project any part of today's discussion for your calculation. What happened? You were only three, or some people joined in between and left? Time is not yet over, right? It's at least till 2:15. That was the last season I watched. She was like very down to earth and naive. When it comes to friends also. How was the day? Did you have classes? Especially the last. I'm excited about the partner. We need to fight next 4:20. But I think them for 4:20. So 45 minutes is more than enough. It's very difficult to engage such all right, you may have the next session. So, will you be able to try to find out the equation to regression line for this data? Yes. Danish, Devin, Harish, will you be able to try to find the equation to regression line?
Yes, sir.
Okay, okay, yes, then do that today evening when you find time. You can do that while listening to music or doing anything you like. Yeah, then in the next session we will discuss that and we will proceed further. Yeah, and don't worry, we will have revision. We will have quite a few revision sessions. Yeah, so we'll revise. All right. Thank you very much. Have a nice day ahead. Thank you
Thank
for
you, sir.
joining. Thank you. Thank you. Bye-bye.